We got cut off there with the last one, so let's look it over here. So what do you do when it's x to the third to the fourth? Now, a lot of students want to just add them, but that would be wrong because what's happening is you have x to the third times x to the third times x to the third times x to the third 4 times. So that means you have three x's here in this group, 3 x's in this group, 3 x's in this group, 3 x's in this group, which really gives you 12 total. Now, how could you get that without having to do this, where you write it out in a string? Well, the answer is you could multiply, right? 3 times 4 makes 12. And that gives you your rule. If you have b to the p to the q, you multiply p times q. All right. Now, those 5 rules, let me just go over them again, right? B to the p times b to the q means you add. When you have b to the p over b to the q, it means you subtract, right? Those powers. 3 and 4 are basically the same thing. They're basically saying you distribute your power when it's all multiplied. No adding, no subtracting, none of that. But if it's all multiplication and division, you can distribute. And number 5 is actually a piece of that as well. You can distribute, but if there was another power in there, then you have to multiply them. Now, you need those 5 rules to simplify uglier expressions, right? Here they are. So in theory, all you have to do is follow those 5 rules and just keep trying and trying and trying and trying until you've made them simplified. Now, what counts as simplified is kind of a mathematical thing. It's not always simpler. It means that it's going to have no parentheses. It means that every variable or constant appears as few times as possible. So you're not going to write 2 different x's, x squared or x to the fourth. You're going to write one x and raise it to whatever power it has. Every number you have is going to be simplified, right? So 7 squared should be 49. That's what you would write. And every exponent is positive. We're not going to have any negative exponents when we're done. That's what makes it simplified. All right, so let's start with the first one. So we have 3b to the fourth, c to the seventh, all squared. Well, there's nothing to do inside these parentheses, so I can't do that. But what I can notice is that, oopsie, sorry. I have this external power outside, and then all the stuff is multiplied inside. See that? So I kind of want to use a combination of 3 and 5. I want to distribute that external power of 2 to the different components, and then I also want to multiply. So maybe rewrite it. It was 3b to the fourth. Oh, I better scroll down. B to the fourth, c to the seventh, all squared. So what I want to do is send that second power in to each one of those individual components, if you will, of this inner thing. Again, there's no adding or subtracting in any of this. Adding and subtracting is what we deal with in chapter 6. It makes things much more difficult. Okay, so what I can do though is use property 3. I can take 3 to the second power, then I can take b to the fourth to the second power, then I can take c to the seventh to the second power. I'm distributing that second power across. Okay. So I used property number 3, distribution. Right. Now I want to kind of clean things up a little bit. This is really, let's see, 9 for that one. And then, I don't need to see that part anymore. So it's 9 for that one. And then it's b to the 8. You multiply. Now I'm using property 5 right there. Right. So b to the 4 to the 2 is b to the 4 times 2, which is 8. And then c to the 7 times 2, which is 14. And you're all done. Right? There's no more parentheses. There's no negative exponents. Every letter is only written once, and everything has been simplified down. Every exponent is positive. It satisfies all 4 of these requirements of being simplified, quote unquote. All right, let's do it again. Now this one's going to be more complicated, so let's take a look. Now you can notice right off the bat that it doesn't have the external power that A did. So on the outside, there was no little number. Like on A, there was that little 2 outside. So that's how I knew I had to use properties 3, well, actually property 3 right there, because it had that little power outside. Right? So I'm going to send it in. Okay, but on the one that we're on right now, not so much. There's no external power. So then what's the point of these parentheses in front? The answer is There really isn't a point, right? Because they're not doing anything mathematically other than to separate your multiplication items. They're not really serving any purpose other than that. You could get the same problem, let me rewrite it, by saying this 2b to the fifth c to the third times this. It's just that math people don't like, especially with the negative in there, they don't like writing it like this. They think it's messy. So they'd prefer parentheses around them so it's very obvious that they're being multiplied. But that's all it is multiplication. You don't really need the parentheses on this one. All right, fine. So that means that we have, and I'm going to rearrange it, 2 times negative 4, right? The two number parts, those can go together. And then I have b to the fifth and then b to the seventh, right? Because multiplication's commutative. You can kind of shove it around whichever way you want, and associative. So I can say, okay, since all of this is multiplication, it's just one big timesing string, then I can kind of put next to each other whatever I feel like. All right. Now 2 and negative 4. 2 times negative 4, we all hopefully know, is negative 8. B to the, now what do you do here? You have a base to the fifth power and a base to the seventh power. That means you have 5 b's on this first one and 7 b's on the last one, which means you have 12 total. You're adding those powers, right? 5 plus 7, if you will. And then C to the, you have 3 here and 6 more, which means you have 9 altogether. Oops. Put that box around that. Now, you've satisfied everything you need to. Every letter occurs only once. There's one B, there's one C. All the exponents are positive. Your number's been calculated to be negative 8. There's no parentheses in the problem. So we're good. All right, let's move on to C. All right, so for letter C, we have, let me rewrite it, 14 b to the 8. C to the fifth over 21b squared c to the third. All right. Now forget about the b's and the c's for a second and just look. 14 and 21. Don't we already know how to reduce that down? Isn't that 2/3? Because 7 goes into this twice, right? Use a 2. And then 7 goes into 21 3 times. So that's reduced down. Now, what about the b's? You have 8 b's on top, only 2 b's on bottom. All right, what's going to happen is that 2 of them are going to cancel away, right? And leave you how many left over? Well, you can figure it out this way. 8 take away 2, right? Which we all know, hopefully, is b to the 6. Now, technically, it's in the numerator if you want to think of it that way, or you can think of it as outside. It doesn't really make any difference. But it's in the numerator, but a lot of people choose to write that out in front or out in the back instead. So 2b to the 6, because 8 minus 2 is 6. Now, what about your c's? Well, you should know right off the bat, again, with the, just like with the b's, there's more c's on top, so your c's are going to end up on the top. Not that that matters for this portion, because even if it wasn't, you'd still be writing 5, take away 3. You write the top number, whatever it is, minus the bottom number, whatever it is. All right, so that means you're going to have c squared. Done. Just for the record, again, I'm just sitting here thinking of this. If it had been 14 b to the 8, I guess you can add this in, 21b squared c. If I had c to the third over c to the fifth, like that, you'd still do the 2 over 3, you'd still do the b to the 6, b to the 8 take away 2, just like the other ones, and you do c to the 3 take away 5, like that. Right? Okay. And again, we'd finish that out and make it negative and all that good stuff. We'll talk about what negative exponents do in the next page. But I just wanted to make it clear that it's whatever that numerator number is, that's what the number you put in front, like 5 on this one. And then whatever the denominator number is, you put it in back. All right, last one on this page at least. All right, so you have 2b to the third, c to the third, all to the fifth power. And then you're going to raise it over b to the fourth c. Well, the first thing you're going to have to do, okay, you can't divide. So what some students want to do is they want to say, oh, I have 3 c's up here, 1 c down here, so I'll just divide that and make c squared. You can't divide until you've dealt with this power, because this is a grouping symbol up here. It is grouped together all the stuff inside those parentheses. So what you have to do first is go 2 to the fifth, b to the third, raise it to the fifth, and then c to the third. Oops, not c, x. Sorry, those buttons are right next to each other. Raise it to the fifth. And then again, it's over b to the fourth, c. Okay? So you don't have 3 c's up there. You have a whole mess of them. All right, let's figure out the 2 to the fifth part, though. The 2 to the fifth, in case you've forgotten, that's kind of one that you honestly memorize just because you get so used to seeing it. It's 32. Right? So 32. Now, this is b to the 3 times 5, which is b to the 15. Again, that's using that property where if you've got parentheses inside, or excuse me, exponent inside, exponent outside, you multiply them. And then it's c to the 15th as well, because it's 3 times 5 over b to the fourth c. Okay, so this is 32. You go b to the 15, take away 4. C to the 15, take away 1. I know you might think 0, but if it was 0, then there wouldn't be anything here at all. So it's 1. This is c to the 1. Mathematicians are lazy, so they don't bother writing 1 powers if they don't have to. And by the way, if everything's up in the numerator, then what's left in the denominator? No, it's not 0, it's 1, right? So there's always a 1 right there. If it was 0, the whole thing would be undefined and we'd be in trouble. All right, so this is equal to 32 b to the 11, because 15 take away 4 is 11, c to the 14. If you like, you can think of it as over 1, but at this point, since everything's over 1, we don't even have to write it. Right? Remember, division by 1, we don't generally write. And there you go, that's that answer. This was really a note. Okay, so we skirted around it with this little note that I was making. What happens if you end up with a negative exponent? Which, let me do it. So this would be 2, 3. This is b to the 6th. Nobody's got trouble with that. But it's c to the negative 2. And if you look back up, if I write negative, if you look back up here, it says every exponent's positive. So c to the negative 2 is going to be no good for you. You're not allowed to leave it. So then the question is, what the heck is it? What is c to the negative 2? And that's a good question. So what it is it's in the wrong place. So it's going to be the inverse, if you will, the opposite. So you're going to put it down here. You move it to the denominator and you lose the negative exponent. It's just a little precursor for what's to come. Right? Because it's right here. See? Negative exponents. So let's talk about it. First, let's talk about what a 0 exponent is. When you have 0 as your exponent, like b to the 0, that is automatically and always will be 1. The number 1. That's what it is. By definition, just know it.